Okay, hi, I'm Lucy and this is Molly, and we go to Langton Girls. Switch on, I suppose. Langton Girls Grammar School, and we were also involved with the CERN at School project. But instead of going for space, we were thinking, what's going on, like right next to us? What's happening here? So obviously, we went for food, because what else would we choose? And we were given an MX-10 chip, much like most of the other CERN at School groups, to collect our radiation data. And yeah, we were also inspired by the GCSE question on our physics paper about the banana equivalent of radiation. It's quite interesting, so we decided to investigate that further.
So to start off with, we decided to test 3 types of food. So as you can see, it was tea, so the tea leaves from a tea bag, freeze-dried coffee, and Brazil nuts. And it showed that coffee and tea were more radioactive than background radiation, so we thought we must investigate this further. We decided not to go with coffee, however. It's freeze-dried, very manufactured, and it's soluble in water, so we couldn't separate the two again to see if radiation had transferred. So we decided to investigate tea further. So we tested it in different states. So first, the tea leaves out of the packet. Then we tried brewing it in hot water, taking the tea leaves out again and seeing if the radiation had transferred. So that would be more important if you're looking at what radiation goes into you when you're drinking tea. Then we tried the hot water after it cooled down again. And then finally, we took out the tea leaves after it had been in the water and dried them to see what effect radiation had on it. So.
Right, first thing we want to say is tea is not dangerous. We're not going to die of radiation poisoning because of tea. You would have to drink lots and lots and lots of, like, thousands of cups a day for hundreds of years. That's a bit dramatic. Do you get my point? But yeah, we believe that the particle doing this is potassium-40 because there was a test done, we Googled, and we found different particles in tea, and potassium-14 was one of them, and it mainly emits beta and gamma. Yeah. And we believe that potassium-40 is the reason behind the radiation. And this could only pose a threat for those on dialysis who struggle to get rid of potassium from their body, because it seems a bit not productive putting potassium back in your body when you're trying to get it out. And so to further test our experiment, we got loads of tea from different geographical locations, and we actually found that these were less radioactive than the one that we actually got, which was Morrison's own, if you wanted to know.
So yeah, this showed that the Morrison's tea, it didn't have any origins on the box or online, so we think it might just be an amalgamation of different types of tea from around the world to make it cheaper. So comparing this to the more expensive brands from specified places, it was the tea that we tested at the beginning was a lot more radioactive than these other types of tea. So we think that this might be either to do with processing rather than the tea plant, so it's something we want to investigate further. So thank you very much for listening.
How long did you expose the chip to the tea for?
I think we did 5 frames of 60 seconds each for each different state.
Okay.
And then we did loads of repeats because we had an anomaly with the cold tea.
Okay.
So we decided to repeat it lots of times to make sure.
Thank you.
Excellent. And there's some down here. On this side, Steve. You're earning your money today, Steve. Make me run around from one end to the other.
My question is, what are you going to do with your results?
Well, what we want to do is we want to get the tea actually tested to see if it is potassium-40, and then maybe test it a bit further, and if it does seem like there's quite a lot of potassium in it, then maybe give it to the FSA. So we don't know. But yeah, it's just to see if people should be warned on the matter. We don't know how serious it is.
Okay, lovely. Fantastic. Well done, everyone. Well, quietly. Okay, one from Will. Just go on, let's go.
Why do you think there's a difference between cold and hot tea?
We think this might be due to the half-life of the potassium-40, if it is potassium-40. Sorry. Oh, okay, sorry. So we think it might be due to the half-life, and also when the hot tea is being recorded, it's steaming, so we use boiling water. So the steam will carry some of the radioactive particles up to the sensor, whereas if it's a cold tea, there's no steam, so the particles won't move as much, and then less will be recorded.
Interesting, very good. Oh, well done, everyone. Fantastic. Thanks very much.